All right, dispersion. Why do we want to study dispersion?
Describes the more than the center.
Describes more than the center.
Tells about the
So with the
spread
mean,
of the
median, and mode, what did we measure?
center.
The location. All right. And by studying the location, we only describe the center of the data. It is valuable from that standpoint, but it doesn't tell us anything about the spread of that data. What is our spread or our dispersion from the middle? The simplest measure of dispersion is what? Range. The range. What is the range? The difference between the minimum and the maximum values. So we could say that the range is equal to the maximum value minus the minimum value. So, looking at your textbook on page 69, down at the bottom, it says refer to chapter 3-6 up above. Find the range in the number of computer monitors produced per hour. So from this Baton Rouge plant, we have (48) through 52 computers being manufactured per hour. So my range, what's the maximum value?
Minus 48.
Minimum value, 48. 4. And the range is 4. Simple enough. What's the weakness?
You're only using 2 points of your data to determine it.
I'm only using 2 points in my data. It's ignoring everything else in the middle. All right, so the variance is going to help us measure the mean amount by which the values in a population or sample vary from their mean. So look at this. We are going to calculate the average dispersion away from our mean. So we're going to calculate the average dispersion around our average. Remember, right here, we're only concerned with 2 values. Now I'm going to take everything into consideration.
Add it up and divide it.
Well, we're not going to add it up and divide it. We're not really calculating the mean, but I want you to remember what the mean is, and we are calculating the mean dispersion around our mean. Let's look at it. So look, the variance, the arithmetic mean, here's our textbook definition, but I want you to stress what I just said. Your textbook definition, the arithmetic mean of the squared deviations from the mean.
That's a lot.
That's a lot to follow.
Show me.
So we'll remember what I just said. And let's look at this example in the book. So first, let's throw a formula here. And I'm on page 73. So the population variance. Population variance. What's my symbol? We start out with sigma squared. So remember, this is the symbol for our population variance. Remember, the population, you're usually using this capital letter. All right, and I'll tell you, this is lowercase Greek symbol. All right, what's x? So here we know we're going to sum. What's the x reference?
Okay.
The value of a particular observation. What's the mu reference? Arithmetic mean. Go back to prior video. And the capital N. The number of observations. All right, so let's look at, I'll give you another example. What's step one for solving?
Find your population mean.
Find the mean. Okay, so we are going to give an example. Citations per month. We done with the range? All right. How many citations did we have in January? 19. February. March. April. May.
28.
20.
28.
28. June.
34.
July.
45.
August. 29.
39.
39. September.
38.
October.
44.
November.
34.
And December.
10.
10. All right, so step one, begin by finding the mean. Someone tell me what my mean is.
29. You want the answer, like, well, how to get it?
Well, I would add this up
And then divide by 12, yeah.
and divide by 12. So the mean is 29. Now what's step 2? Remember, we're calculating the mean dispersion around our mean. So here's the mean of all of our data, 29. Next, we've got to find the difference between each observation and the mean.
So you're taking 17 from, 19 from 17, that's 2. 17 from 22, that's 5. 22 from 18, that's 4. 18 from 28, 28 from 10. 34, 6. Is that what you're doing?
Correct. So in our first observation, so let's look at it. Here's our citations. So now we are trying to find what is each unit, what's the difference from our mean. All right, so in the first one, what do we have?
Negative 10.
How'd you get negative 10?
What am I subtracting? 29
Oh,
from 19.
okay.
Okay, so what's my next value?
Negative 12.
Negative 12. Let's keep going.
Negative 7.
7.
What's next?
Negative 11.
11.
What's next?
Negative 1.
1. Positive 5.
15. 16.
16.
And
10.
Well, here I switched to positive.
yeah, 5 and then
You have-
16.
5 and 16,
10.
10, 9,
15.
15,
I mean, 5
5,
and 19. I felt like my symbol math was failing. 19.
19.
19.
So you put positive together?
Look at the top of page 74.
Oh, yeah, I mean negative 19 on that last one.
So here I'm at 10, so negative 19. All right, now step 2 is we want to take the square root of each of these values. So the square root of 10 is what? The square root of minus 10 is what? 100.
Hold on, what step is this?
We're taking the square root of each of these values.
It's the 4th column on that chart.
So 100, 144,
49.
49, square root of negative 11,
21. 121.
square root of
1.
1, square root of 5,
100.
square root of 16,
16. 56.
10,
100.
9,
81.
15,
225.
5,
25.
19.
361.
Everyone knows when you multiply two negative numbers by itself, you get a
Positive.
positive number. What's the last step? We sum this, we get 0. We sum this, from the book, we get 1,488.
Charlie, just a point of clarification question. So when we are finding, we've done the mean, sorry, the audio is horrible, and we're looking for the difference between the observation and the mean, we always put the observation subtracted by what the mean is. So that's how we get the negative number, correct?
Correct. Observation from the mean. So now we have summed this to 1,488. And what are we going to divide that by? Remember, here's what we just solved for.
12, right?
Divided by 12. And we get a variance of 124. Now let me point out that when we calculate the variance, the numbers that we used here, remember, we square them. So by taking the square root of this number, we can transform it to the same unit of measurement that we had in the beginning. This is my variance. Now, if I take the square root of this, where's my formula for my variance? So my square root, just going to call it that. What's the square root of 124?
11.4.
11.14. Okay, so if we're looking at the dispersion, here we're talking about the number of citations written in each month. We said that the average was 29. You with me? Does that mean that every month we had a difference of 29?
Yeah.
No. For planning purposes, I could assume that on any given month, my values would be 29 plus or minus 11.14. That would be the relative range that I would expect the number of citations to come in. This is your standard deviation. So the standard deviation is the square root of the variance. And remember, all we do is we take the square root because we're having to square the data here. And we want to put it back in the same levels of measurement that we're using up here. We got to take the square root of it.
So
That's
20,
a standard deviation, you said?
This is the standard deviation,
Square root.
the square root of the variance.
so that 11.4 is plus or minus of the 29.
Of the 29. And that's how you would interpret it. In practice, all right, here's how I use this figure every single day. Let's assume that you are taking a look at choosing an investment inside your retirement plan. And you see where Fund A, and we're calculating, let's say we're going to calculate gains back to 1920. So if we're looking at stock market gains in the periods of 1920 to 2016. And we have investment A. And I tell you that its mean is 8%, and it has a standard deviation of 26. And then investment B has a mean of 6%, with a standard deviation of 5. And you're trying to explain to someone what they might expect by choosing either one of these investments.
A is riskier,
A is riskier. Why?
because the standard deviation is way higher. So it means there's more room between the mean and the outside edges.
In this case, I'm using the standard deviation as a measurement of volatility. I'm saying to the potential investor, hey, over the course of this time period, this investment produced an average annual return of 8%. However, during this time period, one might have expected plus 26% or minus 26% off of this mean. So you could have expected a 34% gain or what? Loss.
18.
A loss of 18%. Option B only produced an average gain of 6% during this time period. However, with a standard deviation of 5, you could have expected in any given year an 11% gain or a 1% gain. Depending on your preference for risk, and I would argue your time horizon, you're going to be able to make a more informed decision.
And but what's investment A? Is it a group of stocks or is it?
That's irrelevant.
Which option do you like better?
A.
What as I said, it would
8%. I'd say
depend on,
8%.
well, it would depend on,
We like security.
it boils down to your preference for risk.
There's no
Also, how
security
close you are to
A.
retirement. Obviously, you want to go with the second one if you're closer to retirement age.
Or if you did not, you were risk adverse,
But I think if
I like risk,
I had individual year information and we just had went through a couple losses on that A, I might try to jump in here and get one quick gains.
Also, it depends on what your disposable income is. If I only have $1,000 to invest, I'm gonna wanna go with the safer option. If I got millions, I'll go with something that's got a bigger risk factor. Cause it's like, hey, I got $1 million to blow, I mean, I might as well try to make that 1 million, 5 million.
we're deviating here. There is no right or wrong answer. I mean, it would really depend on each individual's position and attitude toward risk.
What do you find with your clients? What do you feel like they go more? Do you have riskier clients or do you have?
I have clients who are very
Small.
speculative, and I have clients who
Everybody's like that.
would
What
not,
is sophisticated?
would not stomach one. They would never stomach the loss.
Okay, your homework, I'm gonna need you to go Oh, and no, I'm kidding. Let us know what percentage is risk to client and what percent. No. I'm just giving you a hard
We'll run a portfolio next week. What, a 12% gain?
All right, so let's wrap some of this up.
So that's what it means. It means it deviates back and forth. Okay.
We good? We good, Wisconsin?
I think we're good. Yeah.
All right.